Hey guys, welcome. We are going to do a review video. We're going to do some problems. Hey, there I am. Alright, so let's get to it. Got my pen, I'm ready. I hope you are too. We're just going to do a couple problems here, and let's see how we do. Okay, first off, I'm going to draw a couple triangles here. Boop, 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 boop. That's a right triangle, and it's really cool. Bum, 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 bum. Alright, cool. There's a right triangle for you. And here's another one, and it's really cool, and his name is Bobaroo. Okay, alright. I guess I really didn't have to, I could have put this up before, but I thought maybe you just wanted to, see what's going on and say, hey, what's up? So, here we are. Alright, boom, look at all these problems, there's so many triangles! Alright, remember one thing. All these are right triangles, but we use different rules for each one of these. So let's go ahead and review which rules we use for which appropriate time. So I'm going to pick a different color here, and let's go ahead and see what I would use for which. Let's go ahead and start here. 4 or 5, how do I find this missing piece? Okay, well, the answer to that would be Pythagorean's theorem. So we're going to set this up as 4 squared plus x squared equals 5 squared. So notice I have no information about angle measures. I have two sides. If I'm given two sides in a right triangle, to find the third side, I can use Pythagorean theorem. Over here, I only have one side, so can't use Pythagorean theorem anymore, but I see two angles are congruent, so I'm going to use the 45, 45, 90 rules, which means this is an x rad 2 position, and this is an x and x. So we'll solve that one in a second. Over here, again, we only have one side, so we can't use Pythagorean theorem, but we see a 30, so that means this is a 30, 60, 90 rule. So we're going to have x rad 3, and 2x. Okay? And then over here, we're finding an angle measure. Well, we can't use angle measure with Pythagorean theorem even though we have two sides. And I can't use special right triangles because this is not a special right triangle. But we can use what's called trigonometry. So we can use SOHCAHTOA and our googly eyes. And over here, we have only one side, which means I could use special right triangles, but since it's 40 degrees, you can't use that, so we got to use googly eyes. Okay? So we have three ways to use right triangles. We can use law of cosine, we can use Pythagorean theorem. We can use special right triangles, 45, 45, 90, 30, 60, 90, and then we can use SOHCAHTOA. Okay, so here, let's get to it. This first one right here, 4 squared, is going to be 16 plus x squared equals 25. Go ahead and subtract, and we get x squared equals, this is going to become 9. Take the square root, and x equals 3. So we get our side of 3. And some of you might have known that 4, 3, 5 is actually a Pythagorean triple, so you actually could probably do less work than that. Alright, on this one here, we got x rad 2. I'm going to use a different color actually. I should have done that in the last one. I apologize. So we'll put our answers in green. 10 is in the x rad 2 position. To find x, we divide by 2 and multiply by rad 2. So this is actually going to be equal to 5 rad 2. And this one's going to be equal to 5 rad 2. Okay. And this next one, x is 6, so 2x, this position is going to be 12. And this is going to be 6 rad 3. So again, special right triangles are super fast if you know the rules. If you don't know the rules, you need practice. Okay? And these videos don't give you practice, they show you how to do it, but you need to practice them. Alright, for these last two, I'm going to move my face over here, and I'm going to write right below my face the key to everything. And it's SOHCAHTOA. Okay? So right here we look across, we have opposite, and we have hypotenuse. So this is going to be the sine of x equals opposite over hypotenuse. And then we're going to take the inverse sine of both sides. That gets rid of the sine over here. And we get the inverse sine of 8 over 10. Okay? And grab your calculator, and we're going to solve that. And so the inverse sine is going to be 8 divided by 10. And we get approximately... Okay, whoops, I think I made a mistake. 1 second. Let me double check my answer. Whoops. Hello. Okay, sorry about that. So we should get about 53.1 if we round to the nearest tenth. And remember, this is an angle, so we're going to talk about degrees. Boom. Alright, on this one we have opposite. Oh man, I did another sine one. That's okay. Opposite over hypotenuse, we're going to take the sine of 40 equals 8 over, opposite, gotta be careful, careful Mr. Smith, opposite, which is going to be x over hypotenuse, which is 8, multiply 8 out, so we get 8 times the sine of 40 equals x, plug that into our calculator. We get about 5.1 equals x. Okay, so those are all the different types of right triangles we might involve ourselves with, which is using SOHCAHTOA, using Pythagorean theorem, and using special right triangles. The only thing we haven't looked at is our law of sines and cosines. So let's just take a look at those real quick, and I will go ahead and draw those triangles. I got a little piece of paper right here. I'll just go ahead and draw them. And we'll go doop-a-doop-a-doo, doop-a-doo, doop-a-doo, doop-a-dum, doop-a-doop-a-doo, doop-a-doo, a-doop-a-doo, ba-ba-ba-ba-da-ba-ba-da, ba-ba-ba-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da-da- Who's your daddy? Is he rich like me? Has he taken any time to show you Well, the two's not working. Where am I going? Hiya! What the heck? Hiya! What's going on? Whoa, that was super weird. It's like I ran out of ink, but it's virtual ink, so it's like, how can you run out of it? Okay, we have two problems here. And one, they're not right triangles. So everything we just did in the last section, we can't use any of it. We can only use law of sines or cosines. Which one do you use for which position? My goal is I always try and use law of sines first. If it doesn't work, then I try law of cosines. So that's my tactic. So I'm going to go ahead and try law of sines first. Okay? So you need the opposites. So here we have a set of opposites. So we can do the sine of 58 over 25 equals, now I need x, and I need this angle right here. Well, I don't have that angle, but I can find it, because 33 plus 58, that's 91. We can subtract that from 180, and we get 89. So this is 89 degrees using my basic math, so we can take the sine of 89. Okay? So law of sines works. We're going to use law of sines here. This one over here, let's see if we can use law of sines. So we're going to do sine of 95 over x. And then we got 22 here, so we'll do 22 on the bottom. Okay, is there anything I can get? How can I get this angle? I can't. Can I get this angle? I can't. So I'm actually kind of stuck there, so I don't want to use law of sines. I'm going to try cosines. Let's see if I have cosine. So I see an opposite pair here. So we're going to do x squared. And then on the other side, we're going to do the cosine of 95. And then I have two other sides, so I can just do 20 squared plus 22 squared minus 2 times 20, ooh, getting really small, times 22. Alright, let's go ahead and solve these, shall we? Alright, I'm going to actually solve this one first, because we can solve by grouping these pieces together. Okay, so I'm going to plug all that in my calculator right now. 20 squared plus 22 squared. I highly recommend you try this on your calculator. And we get 884 minus, now I'm going to plug all that in my calculator, 2 times 20 times 22 times the cosine of 95. That gives me a negative 76.7, we'll call it. Okay, this is equal to x squared. Then two negatives make a positive, so we're going to actually add those two pieces together. We get 960.7. And then we're going to take the square root. And we get about 31 degrees. Or sorry, 31 length, not 31 degrees. Okay, so that was law of cosines. Now we're going to do law of sines. Over here we're going to cross multiply, so we get 25 times sine of 89 equals x times sine of 58. Then we divide by sine of 58. And divide this side by sine of 58. And we evaluate that piece in our calculator. So I do the first part, 25 times sine of 89. Equal that in my calculator. And then I'm going to hit divide by sine 58. And we get 29.5 if I round. And there it is. Okay, that's basically the whole chapter. The only thing I did not go over was using angle of depression and elevation, which uses SOHCAHTOA. So that's the only thing we didn't cover in this. So, but yeah, that's pretty much the whole chapter. All right, in a nutshell. So there you go. We're done. Hasta luego, I think. Goodbye.